So today we're talking about rational equations. This is really lesson 4.4. These are kind of some old notes, but they were the best notes that we had for this. So today we're talking about distance equals rate multiplied by time. So remember that if you are working with distance and if you need to solve for time, you would divide both sides by r. So t equals d divided by r. This is all math 1 stuff. Or if you knew the distance and the time and you needed to find out what the rate was, you would know that distance divided by t equals r. So that whole idea is really what these first 3 questions are about. Okay? So upstream and downstream. Reuben went canoeing on the Neuse River last Saturday. He traveled 20 miles downstream and then turned around and traveled the same 20 miles upstream. So what was his distance? 20 miles each direction, right? So the distance is the same, up and downstream. Okay, so that's important. You want to know that the distance is the same. The trip took him a total of 7 hours. If his canoe travels 8 miles per hour in still water, what is the speed of the current? So when you travel downstream, you are moving with the speed of the current, right? So the rate is 8 plus the speed of the water. When you travel upstream, you're traveling at your rate minus the speed of the water because it's going against you, okay? We know that the distance is 20. We have to write an expression in terms of time. Okay, so we have to identify what T1 is. Well, remember that if D equals R times T, then T is the distance divided by the rate. So T sub 1 equals the distance, which is 20, divided by the rate, 8 plus C. Does that make sense? Do you guys understand where I got that information? Okay. So if I want to write an expression for the time of T2, let's see. T sub 2, well, that's the distance I traveled on the second trip, 20 miles, divided by my rate, which is 8 minus C. We know that the total time they traveled was what? 7 hours. That means that T1 plus T2 has to equal 7 hours. Yeah. That means that T sub 1 plus T sub 2 has to equal 7 hours. So what do you think we're going to do? Well, we're going to substitute in the expression that we wrote for T sub 1, 20 over 8 plus C, added to the expression that we used for T sub 2, 20 over 8 minus C, and we're going to set it equal to 7. Okay, we're not going to solve this. We're not going to solve this yet. Okay, but it says, congratulations, you just wrote a rational equation. Oh my gosh. You just wrote a rational equation. What do you think a rational equation is? What is asking you, what is a rational equation? Well, we all know that rational numbers are numbers that can be written as what? Fractions. Who said that? Good job. Yeah, rational numbers are numbers that can be written as fractions. Rational equations are fractional equations that have a variable in the denominator. So let's see. Rational equations are fractional equations with variables in the denominator. Now, we have been working with variables in the denominator, right? We've been doing rational expressions and rational equations all week. So the only difference is now we're applying that same concept to real world applications. Okay. That's the difference. We're applying to real world applications. So turn the page, if you would, please, and thank you. Oh, here. All right. All right. So now let's talk about solving the equation that you just wrote. So remember, in order for us to add these two fractions together, they have to have a common denominator, correct? Yes or no? Okay. So I am going to multiply this first fraction by 8 minus c over 8 minus c. That's just a fancy looking what? It's a fancy way to write the number 1. I'm going to multiply this fraction by 8 plus c over 8 plus c. Okay, let's see. 20 times 8, well, that's 160. 20 times negative c, well, that's negative 20c, plus 20 times 8, that's 160. And 20 times a positive c, that's a positive 20c. Over, I'm just leaving it just like this. 8 minus c over 8 plus c. Because that's what these end up becoming, right? Equals 7. Okay, so let's do some cross reducing first. I can get rid of those, right? So what does that give me? That gives me 320 over, I'm going to FOIL this out. What does that become? Minus. So do you guys remember what these are called? These are called conjugates. When you have conjugates, the middle term cancels out. A negative 8c and a positive 8c cancel each other out. So I really just have 64 minus c squared equals 7. I'm writing that as 7 over 1. How do we solve something like this? It's a proportion. What am I telling you to do? Cross multiply. Is that you, Manuel? You were rocking this out. Okay, so what's 7 times 64? I don't know. Well, 7 times 4 is 8, 42. I think it's 448. Is that right? Did someone do the math? 64 times 7 on a calculator? Minus, yes it is. Minus 7c squared equals 320. Okay, now what? Do you guys understand that I just cross multiplied? Okay, so now what am I going to do? Yeah, subtract 448 from both sides. Okay, so let's see. Negative 7c squared equals negative 128, possibly. Is that right? Okay. Trying to get c all by itself, what do I have to move away first? Divide both sides by negative 7. Does 128 divide by 7 nicely? No, it doesn't. But I do know that a negative divided by a negative is a positive. How do I get c all by itself? Because right now it's c squared. Whatever I do on one side, I have to do on the... So c equals whatever the square root of 128 over 7 is. Can someone tell me what that is to like 2 decimal places? So square root 128 divided by 7. There are calculators up front, but I thought that all the desks had at least a calculator on them. No? Here, we'll pass some out. You can just put them away when you're done. Calculator. 4.276. So if we're rounding to the nearest like if I want 2 decimals, 4.276 is going to round to what? Yeah, 4.276 is going to round to 4.28. And we're talking about the speed of the water, miles per hour. This is the speed of the water or the current. Okay. Questions? All right, we're going to do another one just like that. Okay, another distance problem. Tell me when you're ready. Zach, you with us? Say again. It's 11:59. Okay, so a small jet has an airspeed, that's the rate in still air, of 350 miles per hour. During one day's flights, the pilot noted that the plane could fly 121 miles with a tailwind in the same time that it took to fly 116 miles against the same wind. What is the rate of the wind? So first of all, what is the speed of the aircraft? 350. So 350 plus the wind, 350 minus the wind speed. Okay. How far did he travel with the wind? 124 miles. How far did he travel when he was going against the wind? 116. Okay, so let's see. I know that D equals R times T, but T equals D divided by R. So my time is D divided by R. My time is D, 116, divided by R. Okay. Says, notice that the plane travels for the same amount of time both ways. That means that we can set each one of those expressions equal to each other. Who said that? Zach, good job. So 124 over 350 plus W has to be equal to 116 over 350 minus W. So this is cool because it's not an addition or a subtraction problem. It's a proportion. It's a cross multiply. So I don't have to get rid of the denominators. I don't have to do any canceling. So I just have to distribute, right? Cross multiply. So I have to figure out what 116 times 350 plus W is and set it equal to 124 times 350 minus W. Calculator bunny, what is 116 times 350? Don't everybody put it in there at once. 116 times 350. 40,600 plus 116W, because remember we're distributing, equals, what's 124 times 350? Yep. 43,400. Thank you so much, sir. Distribute minus 124W. What do you want to do next? Subtract. Yeah, I would. Can I write it all out at once? I'm going to add 124W to both sides. I see that I dropped my W there. Sorry, fixing it. And then I'm going to subtract 40,600 from both sides. So this cancels out and this cancels out. Let's see, 116 plus 120 is 240. W equals 2,800. Is that right? Is someone doing that math? I think it should be. Yes. Thank you. Okay, so now we divide both sides by 240. So what does W equal? What's 2,800 divided by 240? 11 point what? 6 repeating? Yeah, 11.6 repeating. So let's just round that to 11.7 miles per hour. This is the speed of the wind. This is the wind speed. Whenever I say this is the speed of the wind, I think of like Toy Story, Run Like the Wind, Bullseye. I know it's silly, but anyway. Okay, questions? Are we good? Yeah? Anybody need more time on this one? Okay, next. Now let's try another type of problem. It's about getting a job done. These types of questions were on the EOC last year, and I didn't have a Math 3 class, but I know that they were on there last year, and they were on there the year before that when I did have a class. So, one road crew can pave a section of highway in 12 hours. A second crew working with newer equipment can do the same job in 8 hours. How long would it take to pave the same section of highway if both crews work together? So let's think about this. Crew number one completes 1/12 of the job each hour because it takes them 12 hours, right? So that means that every hour they're completing 1/12 of the job. Whereas crew two, it takes them 8 hours. So every hour they're completing 1/8 of the job. Does that make sense? Okay. So working together, they will complete one of the T, time being per hour, to complete the whole job. So here's what happens. We set up an equation. 1 over the time of the first crew plus 1 over the time of the second crew equals 1 over the time when they work together. So how are we going to solve this? Well, we got to find a GCF because we have to have a greatest common factor. So what's a number that both, or a least common denominator, what's a number that both 12 and 8 go into? 12? Oh, that's what they're divisible by. I want to know a number that they both go into. 24. What about that little guy T? So 24T. So listen, so we're going to multiply everything by 24T over 1. So what do you think is going to happen to the denominators? They're going to cancel out. How many times does 12 go into 24? 2. So this is really 2T times 1. That takes care of the first fraction. Plus, how many times does 8 go into 24? So this is really 3T times 1 equals, do you guys see what I'm doing? How many times does T go into 24? 24 times, right? Like the T's cancel out, you're left with a 24 times 1. So what do you have? You have 2T plus 3T equals 24. 5T equals 24. Divide both sides by 5. And what do you find out? Well, T is 4.8 hours, I believe. Meaning if both crews work together, they can get that same section of highway done in 4.8 hours. What do you think? I love these types of questions. Okay, another way to look at this, another work problem. A bathtub can be filled in 6 minutes. A bathtub can be filled in 6 minutes. It takes 8 minutes for the tub to drain. So since we're draining the tub, do you think that we're going to add the two of these together or probably subtract them? So what's the work time for the first job? 6 minutes to fill. 1/6. Minus, how long does it take to drain it? 1/8 equals 1/T. What's the least common denominator, a number that they both go into, the smallest number? I mean, we could use 48, right? Not 18. 24 again, 24T. So we're going to multiply both sides of this equation by 24T. So remember what happens. We're trying to clear the denominator. That's the goal. How many times does 6 go into 24? 4. So this cancels out to 4T. So I have 4T. These cancel out. How many times does 8 go into 24? 3 times, right? So this is 3T. 3T times 1 is 3T. The T's cross reduced. 24 times 1 is 24. So 4T minus 1T is, 4T minus 3T is 1T. So if I run the faucet, but I leave the drain open, that's what the question was. I didn't even read it all the way to you. Sorry. If I run the faucet to try to fill up the tub, but I leave the drain open, it's actually going to take 24 minutes to fill the tub with the drain unplugged. I don't know who would do that, but you never know. Okay. Alrighty. I'm going to stop our video. Possibly.